Welcome to this presentation on cryptography, and this we are specifically focusing on the modes of operands, and we are going to explain the three: electronic code block, the cipher blockchaining, and the counter mode. Right. So we're going to start with electronic code block, and this one is the most straightforward mode of operation for block ciphers. So in electronic code block mode, the plain text message is divided into fixed size blocks, such as 64 or 128 bits, depending on the cipher. So each block is then encrypted independently using the same secret key. So the encryption process, for example, for each block does not depend on any other block. So the cipher takes a plain text block as input and produces a cipher text block as output using the encryption key. So this independent processing means that if the same plain text block appears more than once in the message, it will always produce the same cipher text block. For example, if we encrypt the phrase hello, hello, hello using the electronic code block, if the hell is one block and the hell that I'm saying is the HEL is one block and the LOH is another, then both the hell blocks will result in the identical cipher text blocks. So this property makes electronic code block very simple to implement and allows for parallel code encryption or decryption of blocks, since there are no dependence between blocks. So however, this also means that patterns present the patterns present in the plain text can be visible in the cipher text, especially if the plain text contains repeated data or structures. Right. Then there is cipher blockchaining mode. This was developed to address the limitation of the ECB, the electronic code block, right, by introducing inter-block dependencies, right. So in CBC, which is the cipher blockchaining mode, before a plain text block is encrypted, it is combined with the previous cipher text block using the bitwise XOR operation, right? The XOR exclusive OR, right? Which is the XOR, which is the exclusive OR operation, right? So this means that the encryption of each block depends not only on the plain text, right, and the key, but also on the result of the previous block's encryption. So to start the process, the first plain text block is XORed, right? It's XORed, right, with a special value called the initialization vector. The initialization vector is a random or unique value that ensures that the same plain text will encrypt to different cipher text each time. So even with the same key, after the first block, each subsequent plain text block is XORed with the cipher text of the previous block and then encrypted. So this chaining effect means that a change in one plain text block will affect not only its own cipher text, but also the cipher text of all subsequent blocks. As a result, patterns in the plain text are obscured, and the cipher text appears much more random. So the CBC, the cipher blockchaining mode, is widely used in secure communication protocols and file encryption because it provides a strong protection against the pattern analysis. Then we move on to counter mode. This one is a modern mode of operation that transforms a block cipher into a stream cipher, right? In CTR mode, counter mode, instead of chaining blocks together, a counter value is used to generate a sequence of unique inputs for the block cipher. For each plain text block, the cipher encrypts a counter value, which is typically a combination of something like a sequential number and using the secret key. So the output of this encryption is called the key stream block. So the keystring block is then XORed with the corresponding plain text, right, block to produce the ciphertext block. For decryption, the same process is used. So the counter is encrypted to produce the key stream, which is then XORed with the ciphertext to recover the plain text. So one of the key features of counter mode is that the counter values for each block are independent and can be generated in advance. So this allows for parallel encryption and decryption of blocks, making counter mode highly efficient and suitable for high-speed applications such as encrypting data in network communication or on storage devices. Since the key stream is generated independent of the plain text, any block can be decrypted without processing previous blocks, allowing for random. So in summary, ECB encrypts each block independently. CBC links blocks together by chaining the encryption, and CTR, the counter mode, uses a counter to generate a key stream for XOR with plain text, enabling parallel processing and stream-like encryption. So each mode operates differently, impacting how data is processed and how secure the resulting ciphertext is against different types of analysis. This marks the end of our presentation on modes of operands, and thank you for listening to this presentation. Thank you.